Today I'm going to explain A-star algorithm. A-star algorithm is a greedy search algorithm which minimizes a heuristic HN function, which is an estimated cost from the node n to the goal state. However, although greedy search can considerably cut the search time efficient, it is neither optimal nor complete. So uniform cost search minimizes the cost Gn from the initial state to n. UCS is optimal and complete but not efficient. New strategy combine greedy search and UCS to get an efficient algorithm which is complete and optimal. So this is the A-star heuristic function, which is f of n is equal to g of n plus h of n, where g of n is exact cost to reach n from the initial state, and h of n is the estimation of the remaining cost to reach the goal. So this is the algorithm. First, you should start with the open containing only the initial nodes. Then set the nodes g value to 0 and g of n value to 0. Then h of value to whatever it is, and we should apply this to until we reach the goal state. If until a goal node is found, we should repeat the following process. If there are no nodes on open, we put failure. Else, pick the node on open with the lowest f value. Call it the best node. Remove from open, place it on close. See if best node is a goal node. If so, exit and report solution. Else, generate the successors of best node, but do not set best node to point to them yet. Set successor to point back to the best node. These backward links will make it possible to recover the path once the solution is found. Complete g of successor is equal to g of best node plus the cost of getting from the best node to successor. See if successor is the same as the any node on open. If so, call the node old. Since this node already exists in the graph, we can throw successor away and add old to the list of the best node successor. If successor was not on open, see if it is on closed. If so, call the node on closed old and add closed old to the list of best node checkers. Check to see if the new path or the old path is better. If successor was not already on either open or closed, then put it on open and add it to the list of best node successor. Compute f successor is equal to g successor plus h successor, which is nothing but the heuristic function. So this is the graph you can see. Here this is the g node value and this is the h node value. From the start to the node is g node, from n to the goal state is hn. So f of n is equal to g of n plus h of n. So this is the graph we are going to take for this example. You can see the graph here and this is the states given. So first you start with the source node. Then these are the three nodes which is coming from the source node, C, E and B. Then you can find that from E there is two nodes which is G, and from G there is another node H, and from H there is a I, which is the whole node. And from F there is a node. This is the path we are finding. So how good is A-star? Memory usage depends on heuristic function. If g of n is constant and h of n is 0, A-star is a breadth first search algorithm. H of n is a perfect estimator. It can be proved that h of n is optimistic, never overestimates the distance to a goal. Then A-star will be find the best solution, shortest path to the goal. When to use search techniques? If the search space is small and there are no other available techniques, or it is not worth the effort to develop a more efficient technique. Search space is large and there is no other available technique, and there exists a good heuristic. Frustration with uninformed search lead to the idea of using domain-specific knowledge in a search so that one can intelligently explore only the relevant part of the search space that has a good chance of containing the goal state. These new techniques are called informed or heuristic search techniques. Even though heuristics improve the performance of informed search algorithms, they are still time-consuming, especially for large-size instances. Thank you.